a student gave to me 12 packets scanning, 11 discriminants, 10 parabolas, 9 x boxes, 8 times table 7.
Alright, so let's go over question number 1.
Y-intercept 5.
Which function has a greater degree? We're supposed to analyze each pair of representations and answer each question and justify our answer. A polynomial function has one relative max and one relative minimum. You should be thinking of another word that describes the maximum minimums. That word is extrema. If I look at my formula sheet, I have the most number of extrema or turning points equals degree minus 1. So extrema equals degree minus 1. Here I have 1 extrema, 2 extrema. So I'm going to put in there 2. 2 equals degree minus 1. I'm going to add 1 to both sides. Therefore, I have at least a third degree polynomial. On j of x, it says negative 10 times x plus 2 squared plus 15x minus 6x plus 2. Now, the long way of doing the problem is if you expand it, there's 2 of them, and then you would multiply those using a box, and then you would multiply by negative 10 and add 15x minus 6x and add 2. That's a lot of work. The easiest way is just recognizing that it's going to be x squared and a negative 10. So, yes, you're going to have a bunch of other stuff in the polynomial, but the highest degree there is a 2. So I'm comparing a 3 and a 2, therefore which one's bigger, greater? The left side is greater. A third degree polynomial is higher than a second degree polynomial, regardless if it's opening up or down. Question number 2. Which function has a greater degree? The first one you have looks linear. And a lot of students think it's linear when you even graph it. Negative 2, 8. Negative 1, 1. 0, 0. 1. Oh, I did it the other way around. Try that again. Negative 2, negative 8. Negative 1, 1, 0, 1, 1. And right 2 up 8. So it looks linear. But let's confirm that using our common difference. Here to here, I have plus 7, plus 1, plus 1, plus 7. Classes, do we have a first common difference? Is it linear? No. So it's not a first common difference, therefore it's not linear. Okay, let's try a second one now. From 7 to 1. Minus 6 to 1 to 1, 0, and then 1 to 7, 6. Do we have a second common difference? No second common difference. So is it quadratic? Not quadratic. Okay, this is new to us. Watch this. If I do a third one, what do I have? Plus 6, plus 6. So yes, a third common difference which we've never talked about before. This verifies to us that this is something to a third power, which is called a cubic. So this represents a y to the x to the third power. That's what cubic is. It's to the third power. So graphing it gives us a visual, and doing the common differences kind of verifies that. Alright, let's look at the right side. A polynomial function n of x that has one pair, that's all they told us, one pair of imaginary zeros. Now, if I draw n of x, and imaginary zeros come in what? Pairs. Imaginary zeros come in pairs. Pairs is how many? And imaginary means it doesn't touch the x-axis. So it doesn't matter if you have a graph that opens up or down. This represents my pair. So, what degree do we have here? This is x to the second power. So you're comparing a third degree polynomial to at least a second degree polynomial. Your answer is left or right side? The left is a greater degree. Remember, as you're taking your test, I don't know, it might just take questions like this. It might give you the same exact one. I can also just cut and paste this picture and put it up here and ask you the same question. So at least hopefully you're familiar with how to think about the characteristics. Number 3, which function has a greater number of real zeros counting multiplicity? So I'm going to circle that word. Multiplicity might be a hint to us. Let's look at the graph one first. I'm going through here and I have 4 distinct zeros. Distinct zeros means like x equals a negative 4, x equals a negative 2, x equals 2, and x equals 4. But something I notice is that, what does it do at those graphs? Does it shoot through or kiss? It shoots through. So shoot-throughs are odds, or 1, and a kiss is a 2. So this is saying you have a multiplicity of 1. So this is a 1, this is a 1, this is a 1, this is a 1. So this is 1, 0, plus 1, 0, plus 1, 0, plus 1, 0. That gives you what? 4 zeros. 4 real zeros, so I know I have a 4th degree polynomial. The degree of the polynomial tells you how many zeros there are. Now on this problem, f of x says 3, that's a positive, right? Positive coefficient, leading coefficient, it's positive. So the arrows are going to stay the same. It's to the 5th degree polynomial, so this is an odd. So my arrows are going to be split like x to the 1st, the line. And then it has a plus 4, so it means it's going to be transformed or translated to the left. Add to x, go west or left. So there it is, 4. And then my arrows are going to start down and end up. And remember, we kind of learned that it comes a little bit flatter at those spots. Okay, this one only has one distinct 0. That's at x equals negative 4. But the degree of the polynomial is 5. Okay, it says counting multiplicity. So you count that. So it's not counting the number of dots or distinct zeros, it's telling you the degree, right? And so our answer is, which one's bigger, 5 or 4? 5. So the left side is correct. Oscar!
Yes, sir.
Pick one, 4, 5, or 6?
I'll do a 5.
Left or right?
Right?
Read it to us.
A polynomial function qx that has an absolute maximum.
What did you draw? You didn't have to draw anything, but...
First, I underlined that it has an absolute maximum.
Okay.
Then I did a graph.
You did or you didn't?
Yeah.
What did you draw? A parabola. And where is the parabola facing? Up or down? Smiley face or sad face? So you drew this. Absolute maximum. It's there. Question, Oscar. What degree is this graph? X to the... Yeah, 1, 2. And that's a negative because it's facing down, but it just asks us about the degree. Class, is this divisible by 2? Yeah. Divisible by 2 means 2 divided by 2 with a remainder, no remainder. Okay? Oscar, pick the next person. Alex, what does that graph look like? It's a line. So left 2, up 4. Now, the temptation is to think that it is a line. Raise your hand if you think it's linear. Okay. The answer, it's not linear. How is a way that we can check that it's not linear? The common difference. So class, how do you go from 4 to 1/8? So is that the same from here to here? Yeah, so not a first common difference. Okay. Does anyone know what this one is? I also think it has a 1/2 to it. Let me think. 1 to the 8th. Does that work? No? Well, we know that it's not linear, right? And if it's some kind of cubic function, the big idea is this. Look at the 3. Class, is that divisible by 2? So the answer would be the right side. Now, when I make the test for, when's your test? On Thursday, I could exactly copy a question, or I might like do something like this. I can paste this description into this side, and you still have to answer the same type of question. Okay? Alex, pick another number for us. 4 or 6? Pick the next person. If you want. Oscar, left or right? Left side? Alright, what does it look like? Read the description for us. So maybe a graph might help. Oscar, what does an odd degree look like? Where are the arrows?
One is up and one is down.
So starts where? Up or down? Well, that would be the case for an odd degree if our A value is negative. But what does this say, Oscar? Positive. So ours should be something like this. Oscar, pick the next person.
What?
What does this graph look like, Tony?
It would
Even or odd degree?
wouldn't it be odd? Oh wait. No. It would be even, no, but then it would start negative because of the coefficient. Yeah, right.
Yeah. Even degree, like x to the second. And he says because the leading coefficient is negative, it's going to go down. Standard form 50 does something like this, right? But the big idea is this. Which function has a greater output? Class, what letter is output? Y. So looking at your y values, which one has a higher or bigger y value as x approaches infinity? Class, which side is that? Left or right? Yeah, x-axis you're going towards the right as x approaches infinity. Okay, so which graph has a higher y value? Left or the right? So essentially what this is looking for is which one has it up here. Which one is that, class? The left side. The left side has a greater output. Tony, pick the next person.
Camille.
Camille, left or right? Okay, what does that graph look like? Well, I don't know if we have to get a graph, but can you read number 4 for us, Camille?
Which function has an LPG?
Question. S of x. What's the degree of this polynomial? Is it to the power of 3? You're correct. Is it to the power of 2? Yes? Is it because you see it as the first one? Well, what we have to do is pick all of them. And if you multiply the same base, you can add the exponents. So Camille, when you add all those numbers up, what do you get? Camille, what degree?
Oh, 7.
Degree 7. Camille, is that odd?
Yeah.
Yeah. Let's double check on this other side. Camille, can you pick another student to help us do the left side?
Tony?
Tony, read that for us.
A polynomial function R of x that has only imaginary zeros.
Tony, what do you know about imaginary zeros?
That doesn't touch the x-axis.
Correct. And how many are there? 1 or 2? Correct. It's like looking at you and your imaginary friend, right?
Yeah.
Imaginary zeros come in pairs. So this represents 2. Class, is this an even or odd? This is like x to the second, so it's not odd.
It's beginning to look a lot like statistics. Every school you go, take a look, oh, it's 12:10. Boy.